This video is about conditions under which a power series will converge. So, power series of the following form. And in this case, z is a complex number, as are all of the coefficients. The main idea of a power series convergence is that it converges in a particular region. So power series, they converge within a region of convergence. That region is actually a disk. And has a radius of convergence. Now, the thing to notice with the power series that I've written here is that it's centered at z equals 0. So for this particular power series, that region of convergence is a disk. It has a radius of convergence, and it's centered at the origin. You can have other centers as well. For other centers, say z0, your power series will look something like this. And the region of convergence will, instead of being centered on the origin, will be centered on z0, wherever that happens to be. And again, it will be a disk. The thing to notice about power series convergence is that inside the region of convergence, you get absolute convergence. Outside, you get no convergence. It diverges. On the boundary, you need to check, and within a closed set inside the region of convergence, any closed set, the convergence is uniform, as in it doesn't, the rate of convergence doesn't depend on the particular z. So some facts. Inside the region of convergence, which is to say, within the radius of convergence, you get absolute convergence. Outside, you get divergence. On the boundary, you must check carefully, and on any closed set within the region of convergence, the rate of convergence is uniform. Now, the first three of these points come from the ratio test. So the tool to prove these things is the ratio test, which says if I have a series like so, this converges if the limit, as n goes to infinity, of the ratio of consecutive terms in magnitude exists and L is less than 1. This is not an if and only if. It diverges if L is greater than 1 and no info if L is equal to 1. So it's not an if and only if. If the limit doesn't exist, the ratio test tells you nothing. Okay, and the ratio test can be applied to the power series. In fact, all you need to do is look at one of these power series here and take a look at the ratio of consecutive terms. So, for a typical power series, let's pick the one that's centered on some arbitrary z0, and let's compute the ratio of consecutive terms. Well, in so doing, it's not so bad. There's the numerator, and there is the denominator. The thing to notice is that the coefficients are just there. They're not really doing much of anything. But the z and z naughts, most of those cancel except for one copy. So you're just left with the distance between z and z naught. Okay, so now all we need to do is we need to compute a limit. So let's take that. So the limit of these ratios of consecutive terms is the limit as n goes to infinity of what? Well, of this value right here. And the thing to notice is that z and z naught do not depend on n, so I can pull them out. If we want convergence, this limit needs to exist and needs to be less than 1. Okay, well, given that, therefore, convergence if z minus z naught is less than 1 over this limit. And by the usual limit manipulation rules, if this limit exists, well, then we can take the reciprocal of it, and that too will exist. And this quantity is the radius of convergence. Now, the thing to notice is that this does not depend on the z at all. And so that's why this is, in fact, uniform convergence. Okay, so that's pretty good. So now we know that we will get convergence within this radius of convergence. That tells us that, interestingly enough, so if the series converges for some z, then it converges for all other points closer to z naught as well. Pretty neat. And so this is typically what you need to do when you want to understand what the convergence of a power series is in fact you just look at the coefficients of the power series. You look at the ratio of consecutive terms, although it's careful, opposite numerator and denominator. From the ratio test. So pay attention to that. But otherwise, it basically works just like the ratio test. In fact, it is the ratio test, as you can see. And that tells you what the radius of convergence is. And then all points closer, you get convergence as well.